Okay, everybody, we have a brand new tutorial. I know it's been a while since I've been making tutorials, but I can tell you straight up, it has been busy here. So many games we've created. But I wanted to do a red light, green light tutorial. It was asked for in the Discord channel. And I thought, I'll do this, but I've been sitting on this for 2 weeks now. So anyways, let's talk about what this is. We've got a button here to start things up. Way over here is our red light, green light, and we're going to see how they change. So I'm going to hit start. Green light. And then I have to stop. Oh, but I didn't stop in time.
Great job.
And I made it to the end. And it stopped. So it doesn't go any further. I'll show you one more time. We stop in time.
Green light.
Green light. Stop.
Red light.
And we don't take any damage.
Green light. Red light.
Hey.
Green light. Red light. Green light.
We made it.
Red light.
Red light. Okay, so there's a few things going on in here. We've got our light that turns red and green. We've got a button that starts everything. And we have a consequence for when you don't stop when it goes red. So let's learn how to create this simple mechanic. Okay, so let's start inside of UEFN. And I want to show you everything that I've got in here. I have a mutator zone. This is a very basic zone that is used in so many games. If you don't know what it is, definitely look it up. But essentially you can use it to detect when somebody has entered space. You could use a player counter, mutator zone, or you can just detect the player position if you want to with code. Mutator zones are really easy to use, so we're going to use that. We have a traffic light that I got from Kitbash, which is a service I subscribe to get all kinds of 3D models that are really cool and detailed. And in here, of course, is the red light and green light. And these actually have materials that light them up. So we'll take a look at that in just a second. Okay, so we've got those items. We've got a button to start things up, which is just a basic button with a different mesh on it. If you go into the details panel of a button, you can see I can use a custom mesh. And I just chose this big, huge red one and set the interaction radius to be a little bit bigger. And that's about all I changed, I think. We have our two spawners, which come with a normal basic island that you can create. And we have our game manager here, which is what we are primarily going to be building. And we have 3 audio devices, one to say red light, one to say green light, and one to say good job. That's all the devices that we've got going on here, all the functionality that is required for this simple mechanic of making a red light, green light. Now we need to learn how to make this happen in verse. But just before that, let's quickly cover what the green light and red light materials look like. I have a folder called materials here, and inside of here is my green light, which looks like this. If we go into the material settings for this material, it's just really lit up green kind of thing, so that this gets set with verse, and that's what the green one looks like. And this is the unlit version of green. Here is the lit version of red. So we're just using this little bit of red here at the top, and this is the red lit up one, and this is the red unlit one. As you can see, it's not lit up at all compared to the red lit button. And then the green unlit is just this one here compared to this one, just lights it up green. So we've got our materials that we can use inside of verse. And we should also note inside of UEFN, we have a bottom light blueprint and a top light blueprint. These are so that we can control the materials that are on them with verse. We need to use a blueprint to control things, which essentially live right inside of here. If we take a look here, I've got a traffic light red and a traffic light green blueprint. These just sit over top of the actual traffic light. So if I were to move this out of the way, you can see that it is the green box light. And the same for the red one. Their origin is exactly the same as the original model, which makes it very easy to place. Okay, so that's everything that's going on inside of the editor here. And I think it's time to quickly wander into verse. Let's learn some stuff. Okay, so on the stage here, we have a verse device. This is what a default verse device looks like. Looks like a computer, because it kind of is. If you're new to verse, then I'm going to quickly go over how to make this, and we'll make it from scratch. It'll be very, very easy, and bring it onto the stage so that we can set up down here in our details. We can set up all of our editables, and our editables allow us to connect verse to the things that are in the scene, like the mutator zone, like the spawners and button and audio devices. So everything that's in here, we need to be able to talk to, and we do that through the game manager. The game manager is something that you make. You can call it anything you want. I call mine game manager, and we're going to make one really, really simple. So to do that, I don't have the window open that I need, so I'm going to go up to verse here and open Verse Explorer. And inside of this Verse Explorer, you can see I have Custom Player and Game Manager, but we're going to make a brand new one just so you know. So you're going to right click here, add new verse file to project, and then we'll call this tutorial game manager. I'm just going to call it something else so you can see, and it just creates default code right away. So just create that, and when that happens, you can double click it and it will open up your verse editor, which is VS Code, which looks like this. So we have our tutorial game manager. It is a creative device, and because it's a creative device, as soon as we're going to save, and then I'm going to hit Control-Shift-B because that's a shortcut for build if you don't want to do that. Or we can go into the UEFN editor, go to verse, and then build verse code. But Control-Shift-B is a shortcut. So I always use that because it's so much faster. So now that I built it, take a look here. We go into our content browser, and inside of here is our tutorial game manager verse class. So what we can do is just back up a little bit here. We take this guy, we just place it in scene. Now I'm going to set up this tutorial game manager just like my game manager so you can see how it's done. Okay, so right now in the details panel, there's nothing other than visible in game and enable to game start. We want enable to game start to be on and visible in game to be off. So by default, it's on, turn it off. All right, so let's make some verse code. All right, so inside of VS Code, we've got this by default. The first thing I always do is I just delete the default code that's in here. Now it's going to give this little squiggly here, and it's going to go red, and it's going to freak you out. So if you're worried about that, just put block. And what that'll do is it'll have the compiler think that there's supposed to be something in here. There's nothing, but at least it won't throw an error. Then we just start from this. This is our base point. Now, the one thing that we're going to need, and I've covered this in past tutorials, is a custom player. We're not going to rebuild this. I'm just going to show you what it looks like. It's very, very simple. This is a class. So this is essentially like a cardboard box that you can kind of put things in and set things on. You open it up and all those things are just in there. So for this, every player is going to get assigned a copy of this box. So it's a class and it's called custom player. And it takes a default value. We have to have an agent object put into it when we create it, and we'll instantiate this later. It's called instantiating or creating or making, whatever it is. And we're going to pass in my agent object as the name of the object, which is agent. An agent is a player. So every player has an agent object. An agent object is just the base object for a player in a game. You need it. You should learn how to use it. It is vital. It is the blood of everything that it comes to messing around with players. Okay, now we're going to make our own stuff here for variables. So var, so not a constant, meaning that we can change this value. Our user ID, I just set a custom user ID for every player so that I can use it to do things later with. We're not going to do anything with it this time, but this is just good practice. And then we're going to grab the red light position of the player. Now this is a vector 3, and a vector 3 is just an XYZ. We're going to make this, but to do this, you're going to bring in this library here. If you didn't have this in, if we just hashtag this out, it's going to chuck an error at us, say, hey, you have vector 3 in here, but we don't know what it is. Did you forget to specify using blah, blah, blah? So we're just going to bring that back. And that will take away that error. So libraries are brought in for the reason of the compiler doesn't want to have to include everything. It only wants to include things that you kind of need. And you don't always need spatial math, but all of my games have spatial math in them. So yeah, it's needed. And then from there, we're going to have a setter. So every variable in your code should have a set. Now we can make this private as well, but I'm just going to leave that stuff out for now in case this is beginners. This is for beginners more. So we're going to set the red light position of the player. So think about how this is going to work. We're going to have a red light and a green light. When it goes green, people get to go. When it turns red, you have to stop. When the light turns red, we're going to set the position, and then we're going to do a comparison later to see where they were or where they are after, I think, 0.1 of a second. We'll take a look at the game manager code in a second, but where they are at a particular amount of time in relation to what they were at when the light went red. That's why we call it the red light position. The POS is the vector 3 XYZ of the player. That's the position. So we're just going to set that and we'll get it later. No worries there. We could make a getter in here, but I didn't. And that's fine as well. Don't worry about it. Okay, so that's the whole custom player. So we're going to instantiate this when a player comes into the game. So let's go into tutorial game manager. We're going to start adding stuff and I'm going to explain how it goes. I encourage everybody to type this stuff out to learn it. Typing is the best way to learn things. Don't copy, don't just take code and just put it in. Type it out, get used to typing it out. It's going to make you learn so much faster. But for those that are too lazy to do that, and I know there are many of you, and I'm actually thankful because it actually drives these tutorials forward a little bit, but I'm very thankful also for those that do want to study. You can find all this code over on Patreon so that you don't have to type it. But We've got 160 lines to write, so let's get on with this. Okay, so I'm going to copy paste in some stuff like this, and we are going to go through what these are. So like every other tutorial I've done, talks about how to deal with players. We want to have a player's map, and this is a way to track our players. We're going to assign a custom player object inside of this player's map, and a map is essentially just an index to a thing. So, you know, if you ever looked inside of a book, you would see that there's an index, and then that will tell you where a particular chapter is or a section is and what page and stuff like that. We're kind of looking at that. It's sort of like a way to find a thing. The key item, so the unique item that's going to go into this so that we can use that to find the thing, it's like a page number in a book is unique. You're not going to have 2 page 5s, right? Just have 1 page 5. So the agent is that. That's the unique key. And then the custom player is the object that goes in that map. Really, really handy. You should learn how to use maps. They're very useful. Used all the time. We're going to set a default unique ID starting with 0. And we're going to iterate on that, meaning we're going to add to it every time we use it. We'll control that later. Okay, we have our editables. These are all editables. And an editable is a thing that allows you to talk to stuff in your game through your verse. So these are all editables. We have our player spawners, which I've made into an array, which is another list, but is just a simple list. So it's the index is only integers, 0, 1, 2, 3, 4, 5, 6, whatever. And it starts at 0. And we're just going to place those in there rather than have player spawner 1 and player spawner 2. It's better to use an array. We have our start button, which is a button device. Just basic button. Nothing more to say there. We have our red light, which is a creative prop. As I said, it's a blueprint. We need to be able to control it. So creative props are what those are. And a green light. And we want to know if the light is green or not. So is green light is a logic or a Boolean. It's a true or false, 1 or 0 kind of idea. Let's set that to false because in the beginning, the game's going to start out with a red light. And then we have our red light audio, green light audio, and great job audio. These are all just the audio player devices we saw on the stage. Very, very simple, but that's what they are. And we're going to just control how sound plays through those. And finally, we have our mutator zone device, which is that green area, and it's called finish area. These are all of our editables that we need to use in the game to control the mechanic of this game. Okay, so now we have a few more things to go through. I thought I would take this tutorial just to a slightly more interesting level because some people are going to want to make games that aren't just sort of one tier, one way of doing things. So we have difficulty levels. We also want to know if the game's over. So we're going to have a variable that's game's over. It's a logic again, true or false. Difficulty level, we're going to set it to 1. So 1 being easy or medium or hard, 1, 2, 3. It doesn't matter what these numbers are. These are just unique values. So you couldn't have this be a 1 as well. It has to be a 2. So these have to be unique. And these names are just for easy reading. Okay, so same thing with the delay to check players, easy, medium, hard. And you'll see how this is used in a second. And the damage, easy, medium, hard. So what we're going to do is we're going to take the difficulty level that we have set of the game. So say we want to make this a hard game, level 3. Then we would use the delay to check players hard, so 0.01 of a second instead of 0.1 or 0.5. Damage easy, medium, hard. So if it's on hard, it's going to set the damage to 100, which will probably eliminate them. So we're going to go back to 1. As you saw in the example when I was playing it, only 20 health came off. All right, so this is kind of extra, but I think this is useful for many people who want to make games that have variable difficulty. Okay, so on begin runs when the device is enabled. So it's enabled by default. So on begin is going to run right away. We're going to get rid of this block and we're going to paste in all the stuff that we need to do by default from the beginning. So the first thing we need to do is make sure that our player spawners have the spawned event subscribed to. If you don't know what this is, I do have 4 videos that describe a lot of the basics. So I don't want to go into this too much, but essentially the player spawner has a event that fires off when a player spawned into the game, and you subscribe to that means you listen for it, and we're going to call on player spawn, which we'll cover in a second. Get play space is the whole play space that the game is in. It has a player removed event, so if somebody leaves the game, we subscribe to that. We're going to call on player removed, which we'll cover in a second. The finish area, which is the mutator zone, has an agent enters event, and so we subscribe to the agent enters event. On player finishes the function we're going to call. We'll figure that out in a second. And I'm disabling that by default because the game hasn't started. When the game starts, we'll re-enable it. The start button has an interacted with event, meaning when you tap on it or when you interact with it, when you set it off, we're going to call a function called start timer for light. And from the get-go, we're going to call a function called change light to red. So let's do the onPlayerSpawn function first. Okay, so onPlayerSpawn, now that I put this in here, you can see this isn't red anymore. It accepts an agent object, and I'm going to call it agent. So we're going to use this. And we want to see if the player exists inside of that map. Remember the map that we made up here? So that is going to control all of our players. And what we do is we want to see if it exists. So if the player spawns again, so sometimes you have games where you spawn more than once. If it's already in there, then we don't need to do anything. We want to put this player in if they don't exist. So else, so if the player exists means this will come back true. This will come back with a thing. If it does, then do nothing. Else, meaning if not, then we're going to make a custom player object. So the custom player is this class. So we're going to make an empty one. It's like making a cardboard box. And that cardboard box has some stuff that we have to figure out for it. So doing that, we say custom player, and then these squiggly brackets pass in the agent from here as my agent object. So my agent object equals : equals. So we're defining it at the same time, agent. Now, if this seems overwhelming, don't worry about it. Honestly, this is just boilerplate code kind of idea. Like, this is code that you're just always going to be writing. It'll just come easy in time. But for now, this is how we're going to define stuff. So we've called it CP, and then we initialize the player and pass in unique ID, and then we iterate on that unique ID with a plus equals 1. This is the simplest way to do this. There's other ways to do it, but I'm just going to give you guys a nice, easy way to do it. And then when we want to set a value of a map, we have to use the option, and then we say set players map agent, which is this object here that came in, equals CP. So then the unique value that we use as the key for the map is the agent, and CP is the object that we're saving in there as we've defined up here. All right. So that's what happens when a player is spawned in. We just save them up. There's nothing else we do. We just want to be able to keep track of them for later purposes. Okay, so the next thing we want to do is we want to figure out what to do when player leaves the game. When players leave the game, we want to clean up the player's map. We can't have just empty player objects all over the place. So this is something that you end up just sort of copy pasting throughout all your code. Once you've learned what it does and why it does it, there's not a lot to really think about here. On player removed gets a player object, which is kind of like an agent, but not quite. So we're going to cast it to an agent object just to be sure. And then if that player object, the custom player object, is inside the player's map, because we now have the agent object that we use as the key. And if we do get something like that, then we're going to remove it. Now, removing stuff from a map is a pain, but this is how you do it. You have to essentially go through the whole map, make a temporary map, put all the other items in that map other than the one you found that you don't want in there, and then you reset up the player's map to be that temporary map, because it'll be the map that doesn't have the one player in it that you don't want in there that left the game. So that cleans up your custom player map. Very, very useful. I just copy paste this every game that I write, and this is how it works. It's very simple. If they had a better way to just remove an item from a map, we'd do it, but this is just the way you got to do it right now. Okay, so we've handled players coming in and players leaving. Very, very important things to do. Now we're going to figure out what to do for the rest of the mechanic. Okay, so let's speed run this a bit. I'm just going to copy in the rest of the code, and we're going to see what we need. We need the fort character here. So you see if you have an item that you're not bringing in the library for, it will tell you. And then we can just copy this here, come up to the top and paste it in like that. And then I think we have one more in here. Get random float requires using verse.org random. We'll bring that in, and you don't have to know where this stuff lives. It will tell you when there's a problem. So up here it's red, so we just need to go find the red thing. So distance is a problem that uses spatial math. So we'll just go grab and come back up to the top and put it in. And now it's green. So now we have no errors. That's really good. So let's now go through the code that makes this game run. So what we have here is change light to red, which runs right from default. I'm not sure how your game is going to run, but my game is run in a way that you have to interact with the button to make the thing work. So changing the light to red from the very beginning in on begin is how I set the default state of the game. So let's look at that, change light to red. And down here, it says change light to red. So this is a function that I've defined. And very simple, the red light audio plays. We set is green light to false because it's not a green light. We then set the red light blueprint to use the red light lit material. We already talked about that before. And the green light to be unlit material. These both live inside of materials. So that's how you can set a material on a blueprint. Very, very handy. Change light to green is done in the same way. Set is green light equals to true. Green light audio dot play. That's how we play a sound in an audio device. And we set up the materials. So the red is unlit and the green light is lit. So these two methods here simply change the lights and set off the sound. Very, very simple. Set up in a way that should make a lot of sense to anybody reading it. So now we've covered everything that runs in here. We need to now figure out what we do when we hit the start button, and we call start timer for light. So right here is start timer for light. So buttons always pass in the agent that pressed the button. So that's why we would have to accept that in here. And we want to see if the game is over or not. And if the game is over, so I mean we're not running the game, that means we can say, okay, start the game. Because if the game's running and somebody hits the button, then it shouldn't do anything, obviously. We could disable the button as well. So that's another way to do it. But we also just want to make sure. It's a good thing to do. So we set the game is over to false because it's not over yet. It just began. The finish area, it's the mutator zone. We enable that. And we spawn start timer. Now spawning, if you're not sure, I've done a tutorial on that as well, allows us to run something asynchronously. So something that runs off to the side along with the rest of our code. And we define that here, start timer, and we add a suspends in here because we want something to happen over a period of time and not finish right away. Start timer for light does that, calls this, and now we have a function that says get random float. Now a float is different than an integer. A float is a decimal point value number, so 1.0 to 5.0, because we have to use this to sleep, which is essentially tell the program to just pause for this many seconds or less than a second. So our random float is a float value, so it's a decimal number. And we're going to change the light to the green and then sleep for that amount, 1 to 5 seconds. So this is what gives us our random delay between green and red, right? So it's a random delay between 1 second and 5 seconds. And that's what get random float does. This is not something I define. This is something that's inside of spatial math. Very, very handy. There's also a get random int if you want to do that as well, but we can't use that because we need to sleep, and sleep requires a float. Whew, hopefully you guys are keeping up with all this. So we set the player's position, which is a different function. We'll cover that in a second. We change the light to red after this sleep finishes. So after the delay of 1 to 5 seconds, somewhere in between 1 second and 5 seconds, we've slept. We put a pause in the program, and then it finishes and it sets the player's position, which is we've covered in the custom player, sets their red light position. Change light to red. So that sounds off that the light's red and the material changes. Then, depending on the difficulty that we set above, we sleep for a particular amount of time. Delay to check players easy, medium, and hard. And this is why we do this in constants, so that we can define this stuff later. If we don't like this, we just change it in one spot. So you might have code that checks to see what should happen if it's easy, medium, hard in multiple locations. But we'd only have to change it in one place here if we wanted to make a change throughout the whole program. So the delay to check is 0.5 seconds. So that's half a second. 0.1 is 10% of a second, obviously. And this is 1% of a second. Very, very short time. And then the damage for easy is 20. Damage medium is 50 and hard is 100, right? So we go down here and we sleep for that particular amount of time, either half a second, 0.1 of a second, or 0.01 of a second, which is very, very quick. And then we check to see if the game is over. If it isn't, then we check the player's distance, because if the game isn't over, then we want to do some action. If not, then somebody already won. Print is a way to show a log, and that's how I do that. So we check the player's distance, sleep for 1 second, and then start the timer up again, which is this same function. So we're just giving a delay in between when we check the player's distance, which is what's going to give the damage, and then sleep for a second, and then start things up again. Set it to green and go red sooner or later, right? So set player's position, as we already know, is a way for us to set the red light position of the player. We do this by getting the Fort character. It's a brand new thing, I know. You can get this off of the agent object of the player from the player's map with a for loop. So a for loop is a way to say, hey, can you go through this whole array or this whole map and just give me all the items that come out of there? So it's not going to come out in any particular order, but for all of the custom players in the player's map, do a thing. And that is grab the Fort character, which I'm going to call FC, Fort character, get the Fort character from the agent object that we saved inside of the custom player. Super handy, right? We grab the position by saying, hey, get the transform and the translation of the transform. So the transform has a whole bunch of information in it. It has the translation, rotation, and scale of objects. And in this case, we want the translation, which is the XYZ, which is, you guessed it, a vector 3. And we set that position here, right? So check player's distance says, okay, what happened? So we know after we've slept a particular amount of time, we need to see if we need to do some damage. And this is easy. We've done distance in the past in another tutorial. We're doing the same thing here. So we check the player's distance. So we go through the whole map. We grab the Fort character and we see what their current position is. And then we grab the distance, which is in spatial math, of the character's red light position to their current position, which we get here. We put that to D for distance. And then I print that because I want to know what it is. And then if D is greater than 100, then we damage the player a particular amount, which is going to be done here. So in the damage player, we're passing in the custom player just in case. We're not using it here, but just in case we want to. And the Fort character, which is what we're going to use to damage the player. Damage is a function on the Fort character. And we're going to do damage easy, damage medium, or damage hard, depending on the difficulty level of the game. That's pretty much it. We're done. That's all the verse code. That's how this mechanic runs. So once we've coded up all this stuff, we can build it with a Control-Shift-B, and that will ask me to save. And then down here is going to be built successfully. And when we go back into UEFN, you can see here that our custom verse device now has a pile of editables ready to be hooked up. And this is very easy. We just kind of go along and just set them up like so. Red light is over here. That, and green light there. Red light audio is this one. Green light audio, job audio, and the finish area. And that sets up our whole verse device to run for the game. Oh, we also need our spawners. So we'll just add 2 items to our array of player spawners and then just pick one and then the other. And that's it. That's how you would set up your own custom verse device from scratch. So that sums up this whole red light, green light tutorial. Hopefully this has been interesting. The verse code isn't that hard, I think, but there's some good concepts in here that I think can be used across many, many games, like setting materials or using the custom player map, and objects, and then of course doing damage to players and figuring out where they are in the game. All very handy stuff. So if you have any questions, let me know anytime, and I will see you guys in the next one.